Okay, I'm not sure if that's the pole. I'd have to ask. The property owner here isn't handy at the moment. But I think, gosh, something like a year ago, during an ice storm, if my memory serves me well, a pole came down, utility pole. This might be the one. I'd have to check. It looks awfully new. The pole pig on it. It feeds the house here on the property. The electric company left behind some of what fell, broken pieces of the pole, some insulators, a couple of cutouts, which the owner here was kind enough to let me have. Someone else had claimed it, but they never came and got it, so I'll remove it and keep it, unless that fella wants it. And if he does, it's his. I really only wanted to have it to document a little bit about this stuff. So, what do we got? A pole like that. It came down. Just broke off. It just rotted. Couldn't take the stress of the weight of the ice or whatever it was, wind. Maybe those two things combined. So, the top part of it at least ended up as a bunch of scrap here. Some of which I intend to reclaim. Kind of cool. Not everybody gets to see this stuff up close. So, let me take this off here. Sorry about the click. Here's a couple of insulators known as saddles. They're porcelain, some sort of ceramic. You have an idea how big these things are. And I know when you see them from the ground up on the pole, they look to be about the size of teacups, but they're quite a bit bigger than that. And I don't have giant hands, but you get an idea. These a little bigger than a teacup. There's a cutout under there, a fuse, another insulator there, a bunch of scrap copper. Forgive my shaking, it's really cold out here right now. Wind. A view of the cross arms as they attach to what's left of the pole down there. It just broke off. Yep. We'll be taking those off and saving them. There are some other insulators and suspensions buried underneath of this pile of rubble. I don't know if I'll be able to get to those. Quite a bit of weight there to do that. There's another cutout. Seems to be all there. We'll be taking that. Broken insulator there. There's another one on the cross arm below it. Down there. Also broken. Yeah. save some of that stuff, if for nothing else, educational purposes. I don't know the story behind these. It looks like low voltage stuff. I'd say low voltage. 120 volts, 240 volts, 241, whatever it takes. I don't know if I mess with that or not. They're some use for those, for stringing antennas and things. So maybe those will go too. Some copper here, not much. I'm mostly interested in these cutouts. As I said, there are two of them. This one is an older one, porcelain bushing and support. And near as I can tell, that fuse is still good. Let's see, 15 kilovolt fuse, I think 150 amp on that one. The other cutout over here is a more modern one. It's plastic. Try and get that out from under there. This stuff weighs quite a bit, and as I said, it's cold out here. I'm not really dressed for it. So, well, put this away and get to work pulling some of this stuff. And with any luck, I'll have further vid of this stuff for anyone that's interested. Okay. Pardon me. And just for size reference, a teacup, typical teacup. Don't know what this is made of. Don't matter. But you get the idea. And as I said, when you see these insulators up on the utility poles, they look, they're so far away when you're standing on the ground. They look to be about this size, maybe a little bigger. But most what you see locally would appear to be something about that size. It ain't. They're bigger and heavier. Let's see. Here's one. You see quite a bit of difference in what this is. It looks like this up on the pole. It really is this, and these are heavy. This thing, oh, this weighs over 5 pounds. It's there's no metal in it. It's all a porcelain, a fired ceramic. Why it has this brown glaze on it here, I am not entirely sure at all. I've looked a little. It seems that there were a couple of reasons for that. One is that it's more forgiving, whatever the composition of it is. It's more forgiving of abrasion and stresses that way, where this, in this case, sort of, oh gosh, off-white, almost a pretty light blue coating might be a better electrical insulator as far as surface, charge migration, and so forth. I also notice when I see these, where it screws on to where this insulator screws on to the support, the metal support, which is essentially grounded, is also glazed with this brown stuff. That may have more to do with the surface stresses. It could also possibly have to do with RF interference. I know some of the most especially telegraph insulators of old were coated with things in an effort to evenly distribute the charges that accumulate on the insulator. In this case, porcelain, in other cases glass, to avoid patches of high charge, which then pop like St. Elmo's fire and cause radio interference. I've seen it, I measured it, it does happen, and this may have also to do with that. This dark brown, almost black coating, glaze on the top of it and inside here, where everywhere else it's meant to be nothing but insulator. Of course, these sit this way. So there's one, and there's another one just like it. Same company, same vintage, it looks like. These are a little bit older, it appears, than this one, which employs the same brown glazing in the threaded part and the brown glazing where the wire sits. Now, these are saddles. For a straight run, the wire, the cable would set along in here, and then there would be tie wires to keep the wire attached to it. But often they'll run the wire alongside of it and attach it that way, depending on things, the angle of the wire coming in and going out, and all sorts of stuff. I'm sure I don't know a whole lot about it. And this one's interesting. It's almost like a cornflower blue. If you can see that, it says ANSI 55-4 0811. That might be a date code of some sort. This one was hanging out on one of the poles that came down on an extending arm. Because of the way things were laid there, I couldn't get the arm, and it was a little bit much anyway, so I just grabbed the insulator itself. So that's what they are. Very, remarkably heavy. This one's heavier than those other two. I think, this thing's 5 or 6 pounds of porcelain. But they were are designed to take a heck of a lot of stress, and not just with the high voltage. These had in situ, they were withstanding somewhere 7,200 volts to maybe 15,000 volts to ground. No mean feat for something that has to be out in the weather and rain, snow, with just dirt and grime, and stresses of the wind and ice and things, branches coming down, pulling on the cables. It's no wonder these things held up as well as they do. These came from a pole that fell. Well, actually, it turns out I asked, and there were two poles that fell. These came from one of them, and they're not broken. They took it. Guy wires, steel guy wires snapped, and the pole itself snapped. It was rotted. Just gave up the ghost. So these are what? Now these to the cross arms on the pole. These things. This bottom part here. There's a hole drilled through the cross arm. Even those, they look like sticks when you look up at them, or when you see one down on the ground up close, they're like railroad ties. You know, it's a pretty thick hunk of wood, and it's that way in both dimensions. So these are heavy, and these insulators, this is threaded, they screw in like that. Oof. I'll tell you, man, he's unwieldy. So yeah, just more for educational purposes. Not just anybody else, but myself included. And I do have a fascination for this stuff. I do collect electric gears such as this. Don't have a lot of distribution stuff, so these are kind of extra gravy. So, ooh, I've got some other goodies from this. Mostly, as I said, interested in documenting what this stuff is. A little bit closer view of things that people may not have much chance to see up close. Got some other goodies, and yeah, we'll bring those up. Okay, so this is one of the cutouts. Think fuse holders off of that pole. It's been damaged because the top part of this pole fell. It's bent, and so things don't really line up very well. More on that in a bit. This is the bracket that supported this piece. This basically bolted to the cross arm, and this piece was attached to here. It's kind of bent up. I don't know if that's because of the pole falling apart, or just the way they tightened it. Nevertheless, none of this stuff is light. I mean, you look up there, it seems like it's so small. Boy, you actually carry this stuff around, and none of it's light. So there's that piece. And so what is this? Oof, heavy is what it is. And here's the mounting attached to the bracket I just showed. This insulator has to insulate off of this. I've got it upside down, but I think up to 13 kilovolts or so. Not sure what this is rated for. The fuse itself, the fuse being this, is rated for 15,000 volts. So let me put this right side up. Oh, good Lord, you'd be surprised how heavy this stuff is. So this would be to the pole, essentially ground, and at the top and at the bottom with the fuse in place, could be 15,000 volts potential between here and here and here and here. The fuse, well, this one's blown, and it does not surprise me. And it's also, this thing's bent probably because it fell. It's amazing how rugged these are, but this one, yeah, maybe I could bang it back in submission, but no reason to do that. What's supposed to happen is the top of this being the fuse, makes contact with this bit up here, which is spring-loaded. And then, so this operates as a switch, and it's got this loop in it, this eye, into which they hook these hot sticks. It's just a long insulating stick with a hook in the end. And these guys, boy, they're a long, long way away and trying to work this wobbly ass thing to hook into this thing, which it's like threading a needle. It has to be. I've never come anywhere close to trying that. But now, so anyway, they can hook their pole into this and pull it out and open up the circuit. It isolates the top from the bottom electrically. And then when these things blow, they can replace them. It pulls out of there. I'll show them. I've got another one of these that is in better shape. Not perfect, but better. And so this is it's a fuse. It's also a switch. So the lineman can come out, and when time to try out the circuit again, he jams this up in there, completes the circuit, and if it doesn't blow, good to go. You know, some of my best friends are electricians, pole climbers, and if they have any commentary about these things, I'd love to hear it. I know some stuff about it. I've never worked on these things at all. I've always been curious about this stuff, so I know a little bit. Anyway, the fuse itself comes clean like that. And there is a mechanism therein. They call these expulsion fuses. Basically, what happens when the element inside of here blows, opens up. Now, this is conductive. It's metal. This is conductive down here. It's all metal. This here is an insulator. But what happens with these is when the element in here blows, the thing that fuses or melts because too much current's flowing through it. When it does that, there's an arc that happens. Very, very quickly, that arc causes a very high pressure to build up in this tube, which blows the element out of the bottom of it. These things sit more or less vertically. And so when this fuse blows, it doesn't just melt and fuse the element in there. The whole thing ejects. It blows out of the bottom of this thing, which does a couple of things. It clears the arc. I mean, when these things blow, it's a pop. It's like a 410 shotgun shell going off. And I wouldn't want to be on the exit end of this when that happens. That would not be fun. This thing's interrupting quite a bit of power. And so it's necessary to not just blow and cause an arc inside and catch on fire. No, it's like a cannon. It blows everything out of it. And when it does that, you see this bit of wire here. That used to be inside here and connected to the fusible element inside. And this was under a stress. There's this spring-loaded bit here, which was held in place by this wire and the tension on it. And that achieved a couple of purposes. One, it kept the fuse inside, the fusible element inside, taut where it should be. But it also gave a signal to the mechanism where this piece doesn't rock if this is cocked, meaning held in place by this wire. So it's held rigid. But when the fuse opens, this wire is let go like that, and this latch moves out of the way and allows this to drop out. So by that, it indicates to someone standing down on the ground, you can see up there it's dropped out of the holder. Kind of ingenious. And I'm sure there's quite a bit more to it than I'm aware of, but that's how this one looks. As far as this fuse goes, yes, it's 15,000 volt fuse, 100 amp. Looks like it says 10,000 amp, probably interrupting capacity. So 100 amps means that this fuse will pass 100 amps continuously and not blow. Some 10, maybe 20% more than that current flow through it will cause it to open, and when it does, bang, blows its guts out and tilts down or whichever, indicating it's a blown fuse. This thing, ooh, I can't believe how much this weighs. This thing easily 15 pounds, and most of it porcelain here. I wonder what it costs to make these things. And I see this chance. I've done some looking around. Chance. Interesting. Is that a brand or is that a type? I don't know. You find out. Anyway, I think that might be a style for the sort of fuse that you would put into the thing. But I've got another one, a more modern one. It was on the same pole. Apparently one of these failed or broken, whatever, and had been replaced. I'll put that one next. Okay. It's the other cutout I had mentioned. Newer model. Let's see. I removed the mounting bracket, similar to the other one. See how that works. Just cross arm through here. That's on the vertical. Yeah. Actually, maybe not. Anyway, there's a mounting assembly for it. As for the cutout itself, well, this is quite a bit different. One thing, it doesn't have the big honking piece of porcelain. This is a plastic material, rubber if you like. Much lighter weight, and same deal. This is where it mounts to the bowl, and the top and the bottom have to be fairly well insulated from this point, this being ground essentially, and this could be 13,000 volts at both ends of it, depending on whether the fuse is in. Normally these sit something like that. You can see this got a bend in it. It's not an accident. Mounted, this would be level, plumb, which would leave this at just a little bit of an angle, like that, or somewhere in between. And this fuse is not blown. It's a 100 amp fuse, 15,000 volt rated. I think in this application it was probably 7,200 volts across, but from top to ground. Not sure. But just from what I've seen, that's what it looked like. But it could be 13 kV. But anyway, this fuse is not blown. The pole this was mounted to came down. It did some damage to this. Again, this chance. Not sure what that's about. I'll look that up. But at the bottom here, that thing still has some weight to it. You can see this element wire coming out of this, the fuse body, is still in there, and it's holding the spring-loaded piece in place. So I haven't even put a meter across this fuse. I know it's good because, well, at least it's got continuity, because if it had blown, this wire wouldn't be still going up in here, and this spring-loaded latch would have come out and dropped the fuse. Interesting. Oh boy, you know, the weight difference between this one and that porcelain one is quite a bit. So yeah, these hang kind of like that, and there's the loop that the lineman can get his hot stick and hook it and pull this out, and pop it in. And these are kind of a sort of a shoehorn deal to guide the fuse home. And there's a spring-loaded bit up here that grabs this. Oh, it's pretty tight. I can get it out. In fact, I will pull that out of there. The top of this would connect to the feed line. The bottom, this bit, clamps to the service line, the load, the output. And it's very interesting how you do this. Most of this is made of steel and other things, but very little copper. There is a copper bit in here, which makes sense. Similar up on the top, there's a copper, I wouldn't call that a bar, but a piece of copper going from where the feed connects right over to where those copper piece goes all the way through to where the fuse actually connects. Kind of cool how they did it. And these things are everywhere. But how many times do you get to actually, fiddle around, look at one, and describe it? I didn't know that these were rubber. I always thought that there was rigid plastic kind of stuff, but nope, very soft. Guess squirrels like it better. All right, so pop the fuse out of here, and it's spring-loaded. What happens when these blow, or when the lineman pulls in? This just drops out, and does this, often swinging like that. And as I said, this has been damaged, trouble with alignment, but when they take this out, that's the fuse. I don't know if they, I imagine they would recycle these and restuff it with a new element. It seems like an awful waste to just toss this whole thing. I don't know. No, somebody can maybe school me about that. But this one's good. And this thing's way up high, and they get this long pole, and they grab this thing some way, and they put it down in there like that. And then they grab it here and get it up and jam it in, switch closed, and if there's still a fault, the insides of this will blow, shoot out guts out the bottom with a bang. It will let you know and open back up. Otherwise it will just be like that. This stuff to me is very, very cool. I'm happy to have had an opportunity to actually put my hands on some of this gear. I may not be its eventual owner, but I got what I need out of it, and it's cool. But I got one more thing besides these insulators and cutouts. This other part that might be of interest. Okay, this final bit here. Not sure how exactly this was used. I've seen these used. They're everywhere. Normally, something like this would be used as an end-of-line termination. Sometimes you'll see something like this for where a line turns a corner at various angles, and these swivel. Pins through these eyes, pin here, eye here, and a sort of clevis, and then a cutter pin to hold it all together. And they can string as many of these as they need together. These two pieces are functionally identical. Well, I say that's not entirely accurate. Both made by Lock, a name I'm familiar with. Maybe you ought to see that there. Brown porcelain, brown glazed porcelain. Very nice looking. Let's see. Both of these, this has a number 74480, and this one 74480. So they're of a type. Although here, this one says 10,000 pounds. Now that's the amount of force this can withstand pulling on this eye from this clevis. 10,000 pounds, man. 5 tons. A lot of weight. And this one here says 5,000 pounds test. And yet, structurally, they are pretty much the same thing. Maybe that's 10,000 pounds, maybe, and we actually tested it to 5,000 pounds. That's force pulling on these guys. Most often you will see these things, this would be bolted to the pole, and there's this giant eye bolt through a clevis, again with a pin and a cotter to hold it together. But usually you see these things more or less, oh God, this is heavy, strung, looking something like that, and the wire, the line attaches some way to this, and off it goes. Just thought I'd throw this in there. Oh, good Lord, I'll bet this thing weighs, 25, 30 pounds, at least, by my reckoning. Like calibrated fingertips. Not a lot to see here. Kind of cool. I don't really need to keep this. I've got enough junk about here. I'm going to pressure to find out the fellow who originally wanted to lay claim to this stuff, and make sure he doesn't want it. Otherwise it'll be probably given away to the first person that is interested in having it. Oh, it occurs to me, Um, two of these could help string up or support one heck of a long wire aerial of very heavy dimensions. Actually, it'd be quite a bit of an overkill. Just radio guys. I don't know what their RF characteristics would be, but well, if you got this to show, who cares? So that'll conclude this vid. Need to be done with it and get this stuff to its future owners, and hope they will enjoy it.